Hello and welcome. I am back to have another go at Harry Gross's Excel dynamic case. Just a quick sort of public service announcement before I jump into it. Harry made a couple of changes to this after I played it yesterday, including fixing a bug that we spotted during my playthrough. This whole kind of Git repo is quite large, and so re-downloading it every time there's a small change is a bit of a pain in the butt. So I've installed, I think it's called TortoiseGit or Git TortoiseGit, or possibly Git Tortoise. So whenever there's a change, I can just go, not actually to publish, but to the root folder, just say git sync and hit pull, and it'll pull all the latest file. I already did it this morning, so I've already got them, but it means that I'm always on the latest version, which is quite helpful because Harry is like adding new challenges regularly, like added more questions for Paul in the curated challenges section, and making kind of small fixes and things all the time. So that is worth knowing. Anyway, let's put on the music. I have reloaded, and let's see. I'm trying to remember what functions I have. Did I get if? I got some good ones toward the end. No, I still don't have if. My God, maybe I should try and get that. And I still don't have sum either. I think I have sum if, which I've been using as a kind of workaround for sum. It would be helpful to get sum and if, but on the other hand, I am determined to get to at least some of the divine levels today. So let's have a quick look, see if we can find who has if and if I can get hold of it. Was it Bo? No, Bo has len, which I also kind of wanted, but part of the fun of this game is working around things you don't have. So okay, Juan has if and also lambda, and oh, I got let. I must have lost it in one of the things with Paul. Anyway, all right, fine. It's worth a quick battle with Juan, but then I'm going to go on to Julien and try and get to the expert level. Oh, that's much later. Okay. Lana can move down, left, or down right. I need to move. She starts with these cells with the highest number of bananas she can collect. Okay. So God, that music's very intense. So we're going to take all of these. See how we're going to do this. Paste that there. Get rid of all of this. Get rid of all of this. And let's just highlight this area. And then put it down here. And we're just going to replace bananas with ones, so it'll make it a little easier to work with. Okay, so then I have max, right? Yes, I have max. So then what you can get from a square is the max of what you can get on the 3 below it, plus the value of that square itself. This is, I don't know, this is maybe old hat now, but this was sort of a revelation for some people that you could do this, what's called dynamic programming. So, you know, if you start from here, there are 3 different places you can go to next, and then from each of those there's 3 places, and by the time you get down 4 or 5 steps, the number of places you could end up is practically infinite. But if you just keep tabs of from here, what's the best you can do, from here, what's the best you can do, from here, what's the best you can do, then from here the best you can do is pick up a banana if there is one, and then take the best of those. And so if you kind of do this record keeping from the bottom up to the top, then it's fine. Now I put it here because there's a header row here and a header row here, so this is cell B2. So now I just have to work around the fact that I don't have indirect, which I've learned a nifty trick for. So I'm just going to paste these here, and then I'm going to say pick some random character, caret, and all of that. Then I'm going to copy value paste, and then I'm going to find caret and replace with equals. And there's indirect with no indirect. And what do I need to do? Just the sum. Okay, so the answer is 332, I think. Yes, good. And what did I get? I got offset, scan, and lambda. Alright. Well, I managed to... Oh, shoot, I meant to start my timer again. Damn it. I forgot to start it on time yesterday, too. Alright, I'm going to battle one more time. And then I'm going to go on to Julien. Okay, Morse code for letters A to Z are given below, and fully competitive for programmer. Okay, so this should be pretty easy. I just need to be able to split up programmer, which I found various ways to do. So, let's see. I don't have sequence, right? No, I don't. It is a good one. Okay, so then we're going to replace in this from 1 up to this -1 blank. Yes, good. And then we're going to replace that from 2 to 10. Good. So that gives me that split into letters. Really got to get mid at some point, but never mind. Now let's look at this in here, return from here. And I don't think I have any hat, but I can just do this. Hooray. Ah, I got if and reduce. Okay, I'll take it. Let's go on. So I think Harry said he had fixed something with Julien, so hopefully the next time I battle him, he will unlock the expert area. Let's give it a go. Unfortunately, all his functions are, sorry Julien, terrible. But anyway, gotta beat him. Okay, this note contains the instructions for disarming the traps in the room that trigger if you don't follow the movement paths. In the top left corner, you can disarm the traps. Trace a path from the center square of horizontally or vertically, from square to square in the order 1, 2, 3. From the center square until you reach the top left square. Okay, so from the 1 you have to go to 2. Okay, got it. Oof. Okay. This is going to be desperately easy. So let's see, the center square is, sorry, this way. Yes, the center square is 4, 4. So if I go with my, that's 404, it's fine, I guess. Oh, I got let. No. Oh, shit. Okay. Well, it's gonna be hard to do without let, I think. Okay, so let's see. Possible directions are 100, -100, 1, and -1. And we need to land on a 2. So this plus all of these. Okay, so we're going to index all of this by, oh, hang on. Yeah, I need these to be going across so that when this is more than one option. Do I have int? Actually, I don't think I need int. I think I just do that over 100. Do I have mod? Oh my god, so many functions I'm missing. What can I use in lieu of mod? Okay, I guess I can say that number minus 100 times round. I do have, I think, that number, oops, over 100 to 0 decimal places. Okay, good. Except that I want this to be across. I'm going to repeat steps so many times here, it's just not even going to be funny. Okay, so that's going to be that, also multiplied by this. Okay, good. So then we're going to say that has to be equal to that. And if it is, then I want this value. So what I'm going to do is divide that by that. Sorry, I want this plus that. I could probably do this one by hand faster than I'm doing it now, but never mind. Okay, wait, no. There's only one true? No, there should be 2 trues. Oh, sorry. Oh, yeah, hang on. No, don't multiply. That's a different challenge. Mixing challenges up. Do not multiply, thank you. Okay. So now, that divided by that is good, and then I can call all of that with 3. Okay, so these are the places that you can get to in one step, which is 6. No, that's not right. We're still multiplying somewhere. Yes, still multiplying there. Whoops. Okay, so you can get to 504 or 405. Yes. If this equals 3, then 1, otherwise this equals 1. Okay. So now you can get to... what? Oh, sorry. Yeah. So let's make it... let's just find and replace I3 with I3 hash. Oh, what? That's not good. Why? Oh, never mind. Just do it here then. G3 hash, 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 and hash. Okay. Oh, do I have unique? I don't. Well, that would have been helpful, but never mind. What? Oh, okay, there's only one place you can get to. Okay, fine. And I'm looking for 101. So do I have count if? Yes. So count if this 101. I'm looking to get to the top left square. That's the goal. I don't know. I might run out of time on this. There's still work to do when I do get there. Oh, come on. How many steps? Oh, there we are. So the first one, it is... Okay, good. Okay, so... Alright. Let's just... want to lock that, and then let's see if I index that 1, 1. That loses it, so then, sorry, so then if I take the second one, that keeps it good. That keeps it good. Sorry, let's freeze pin so I can see this. That loses it, so sorry, so take the 1. Oh, shoot, what? Okay, sorry, there we go, that keeps it. I'm just trying to work out wherever the path branches. I need to figure out the route that we're taking. So I'm just figuring out this. Is there still a 101 in this position if I trim the path various different ways? So where's my last index? Here we are. So 504 doesn't get you there, but 502 does. That does. That does not. Not that one, so that one, yes. Nothing's changed there. Oh, and there. That's it. Okay. Okay, so now what is the question? The sum of the something? Answer the number of squares. Oh, for God's sake, I didn't have to do all that because I just needed the number of squares. I must be thinking of a different game. Okay. Including the starting cell, I think it said. Yes, so 31 squares, if I've got it right. Yes! Bit or and hex to bin. Thanks, Julien. So helpful. And let's face it, don't blame Julien. Thanks, Harry. But anyway, he did get rid of the moose, so now I have access to the expert area. So here's Katrina. Hi, my name's Katrina. I do great work marketing FMWC and XL Esports. I'm a big fan. There are a few submitted challenges that were too hard for mere mortals. Would you like to try one? Okay, what does she have? Choose rows, choose calls. A bunch of date stuff. Okay. Sorry, Katrina, those don't seem like the most useful things. I know Michael Jarman is up in the top left corner. He's the one who has the divine challenges, but I'm going to see if I can get any. My name's Ashley, and I love the XL community. Me too, they're fab. That is pretty much what I would say. I might not use the word fab. In my time there, I've picked up a few tricky challenges. Alright, what will you give me? X, fact. Fact double. Harry. M mult, M round, M unit, N number value. Okay. Sorry, Ashley. None of those seems terribly useful either. Here's Amber. I'm Amber and I do regular office hours with my friends. That's awesome. Do you want a battle? What have you got? Average, average ifs, large, sort, 2-row, unique. Yeah, okay. You've got good stuff. Let's battle. Boom. 15 minutes, okay. What is the question? Oh, triangles of friends. I remember this one well. Alright. I can just remember the answer, but that's not really in the spirit of the question, obviously. Let's get rid of all of this. Let's do 4, for instance. Right, alright. So first thing I'm going to do is just find and replace question mark with 1. Sorry, I meant to match entire cell contents, but never mind. It always spins for a while after you do a bunch of replacements. Oh, and it's replaced those with 11. Oh, that's kind of annoying. Alright, never mind. Doesn't matter, I guess. All I need is the list of connections. Okay, so then we're going to say to call if this, then this, otherwise 1 over 0. And same thing, but for, oh, so these are all the pairs, and then for each of these I need to figure out how many friends they have in common, which shouldn't be that hard. So do I think I have match? Yes, I have match, okay. Okay. Yeah, so that'll overcome, but that's okay. So then I'm going to index, so index on that by that and 0, and index on something by f equal 4 and 0. And I'll say that is not equal to that. And just to be sure, I'm going to put brackets around that part. And then I want to put minus minus around all of that. And that's going to give me that. And then I can't sum that with sum if. Ugh, annoying. But let's just move it over there, and then I can sum it with sum if. So we'll say sum if. Do I have ifs? No, I just have if. So I'm going to sum this where this is 1. And this part I need to lock. Good. They're not the same size? There they are. What? Oh, sorry, yeah. God, I always forget the order. Okay, sorry, it's these first, because it's sum if and not sum ifs. Okay. So then, that looks like way too many. Oh yeah, sorry. I need both of these to be friends, not just. Relax, you got 11 minutes, but yes, okay. So I need that index not equal to blank, and this index also has to be not equal to blank. That is much better, much smaller numbers. Okay, so that sums to 642. So 642, and each friendship is being counted 6 times for 6 different orders. So like Aaron, Betty, it's going to be counted again for Betty, Aaron, and then for each of these 2, so divided by 6, and that is indeed 107. Sorry, Harry, I didn't have mmult, or I would have done it with matrix multiplication. Okay, that gives me vstack, wrap calls, and sort, all useful. I feel like I'd also like to get unique, if I can. So I'll try Amber one more time, and then I'm going to go fight Michael. Where's the smallest possible sum you can select from this 5x5 grid such that no 2 elements come from the same row or column? Okay, so you got 1 to 5 and 1 to 5, so I've got index, right? So then this should be fine. So you can go from 1 to 1. If this equals 5, then this plus 2, divided this plus 1. And so if this is less than that, then 1 0 plus this. This is old-fashioned, you know, pre-percom, pre-other trickery ways of generating lists. Except you're doing it wrong because it should be that plus 1. So this is 1 plus everything up to 5, 2 plus everything from 2 to 5, 3 plus everything from 3 to 5, 4 plus everything from 4 to 5, and then it breaks in the last one. That's fine. All right. Actually, I think I could if I said less than or equal to. I think it might even work up to the last one. Yes. All right. So that gives me. These are all the ways that I can pick. Ooh, whoops. Down there. These are all the ways that I can pick a start and an end point between 1 and 5. And then I just need to do. Let's go down again. So then I can say, just pick a random one here. I can say index this lock by this and this colon index. Same thing. Lock by this lock and this lock. And that gives me that range. So it's from 1 to 5 in one direction. Now it's from I think about from 1 to 5. Alright, let's be a different one. So it's not symmetrical. So here we're going from column 1 to 3 and from row 2 to 3. It gives me that. So then what's smallest possible sum? Oh shoot, sorry, this is a totally different question. Oh my god. Ah! Sorry. I thought it was asking for something about, you know, sub-rectangles with certain properties, but it's not at all. It's asking a totally different question. So this is another old-fashioned pre-percom thing we're going to have to do. There was, long ago, before 2-row and 2-col, there were ways to get permutations, and I'm going to show you one of them. So we do that, and that, and this. I'm going to show it to you in a slightly distracted way because I do have to get this done in 7 minutes, but the basic idea is you have, actually let me color because it'll make it easier to see. So we'll make this one orange, we'll make this one green. Yeah, let's just open this up for now. So the orange just swaps the last 2 positions, the green shuffles these 2 back by 1, and these 2 back by 1. And so orange, green, orange, green, orange, green gets you all permutations of the last 3. Orange is effectively giving you all permutations of the last 2, along with the one it's pointing at. So then I need something that will shuffle the next position, which isn't going to be green in the end, but we'll fix that in a moment. So that will be blue. So then blue shuffles my starting position, and then applying this mix to blue gives me everything there. So now I've got everything with 2 here, with 3 here, with 4 here, and with 5 here. So that's 24. So that's all my 4 factorial combinations of the last 4. And then finally, I do the same thing here to shuffle everything else along by 1. That's whatever, make that purple. And so everything down as far as purple is all the permutations starting with 1, and applying the same shifts to this one gives me all the ones starting with 2, and then with 3, and then with 4, and then with 5. Okay. So now I need to index this lock by this and this. I think I can just do that. Yes. And then sum if. So where this range lock is 1 and sum this. Still ridiculous not to have sum, but anyway. Okay, so I'm interested in the minimum of these, which is that. I think smallest, but yes. Boom. Harmine and XR. Thanks a lot, Amber. All right. Well, it's been probably more than 2 hours because of my forgotten timers. There he is, the giant with his belt, Michael Jarman. Champion of the world. I am Michael Jarman, the reigning XL world champion. I'm starstruck. And so you should be. Beware, I set the hardest challenges in the game. What does he give me? Aggregate, combin, Corel, GCT. Okay, group by is actually useful. pivot by, sort by. Okay, a mix of useful and completely pointless stuff. Thanks, Harry. Alright, just quickly, where am I now? I've made it to Junior Analyst 1040. I've got 4 Expert Challenges down, 10 Advanced. 0 Divine, but Michael is the one who gives the Divine Challenges, so let's see. If I blow it, then I'll go get more functions. Half an hour, oh boy, this is going to be big. Consider all the different ways. I think I might have done this one in one of my test runs. Consider all the different ways of representing a positive integer using nothing but positive integers, addition, multiplication, and parentheses. For 5, 6, 7, 8, a few such ways are 12 times 17 times 167, 5, 6, 7, 8. Multiply all these. Okay, fine. For each such representation, consider the sum of the integers involved. Okay, so 2 times 17 times 167, you add them up, you get 186. And so on. For 5, 6, 8, 7, the minimum possible sum for any representation is 27, which is something like this one. The minimum possible sum for a given integer is known as its integer complexity. The integer complexity of 5, 6, 7, 8 is 27. The integer complexity of the numbers 1, 2, 3 is this. The sum of the integer complexities for all numbers from 1 to 100 is 1113. Find the sum of the integer complexities for all numbers from 1 to 1000. Okay. So let's just start off with some experimentation. Go Alt-AE, delimited, next, space, finish. Okay, that's right. So this is one. Okay, so for 1 you can just do 1, for 2 you can just do 2, for 3, 4, 5. The first place you can save is 6, which I guess is 2 times 3. Oops, 2 times hashtag. 7, I guess is 2 times 3 plus 1. 8, 2 times 2 times 2. This is 9, 3 times 3. 10, 2 times 5, I guess. Or 3 times 3 plus 1. I noticed that in the example, the one that was most efficient was all about multiplying 3s and 4s and adding 1s, which is interesting. Probably a pattern worth looking at there. Let's see. I guess for any even number, you can always do 2 plus half of it. For any odd number, you can always do 1 plus half of it. Sorry, 1 plus 1 less than it, I mean. So I guess one question would be, can you ever do better than that? This minus this. Yes, you can sometimes do better than that. We need to think more. Alright, we've still got time. Okay. So I guess yeah, you're either going to multiply 2 smaller numbers together. If it's not prime, that's almost certainly going to be the best way. So let's say for 12, you'll multiply 3 by 4, which you can get in 3 and in 4. And for 20, you'd multiply 4 by 5, which you can get in 4 and 5. So you'll either multiply 2 smaller numbers together, and then it's just a question of which combination will work best, or you're going to add. But yes, now I remember. So adding, the best option only ever added 1. You multiply 3s and 4s, you add 1. So I think if it's a prime, we're going to say 1 plus the number that comes before it. And if it's not, we're going to look to multiply smaller numbers. Okay, so... oh god, I still don't have sequence, do I? Oh, that's such a pain in the butt. Alright, whatever. I'm interested in the numbers up to 1000, which means that my potential list of prime divisors is actually pretty small, so I can probably just list them by hand. Let's do that. So 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31. And that's it, right? Because 32 squared is 1024. So any non-prime under 1,000 will have one of these as a factor. Can I give it a name? Yes. Okay, cool. Alright, so let's just take 15. I'm going to say prime divided by prime less than this. What? Oh. What? Oh, you deleted the name, you sneaky queen. Ugh. Slippery Harry. Okay. So then I can call that by 3. So these are potential prime. Actually, sorry, hang on. Less than that to the power of 1/2. But now let's make it less than or equal to. Okay, so the only potential prime divisors are 15 or 2 and 3. Cool. Then we're going to say that over that. Wait. Do I have H stack, B stack? I have. I got V stack. Do I have H stack? That would be more useful here. I don't. Do I have 2 row or transpose? Wrong orientation. Thanks. I don't have either 2 row or transpose. Ugh. Fine. It doesn't matter. Let's just. Wait, do I have 2? I have if. Yeah. Okay. So I can say if 0, 1, then that or. It could be more efficient if I had let, but I don't have to be. Okay. I have to get rid of. Yeah, no, hang on. I'm gonna do better than this. I'm gonna work with this first. Do I have any int or anything like that? No. I don't have int, I don't have mod. Oh, I have round. Yes. Okay. Still don't have let, do I? Ugh. Let would really be helpful for these big ones, but fine, I'll just be super inefficient. Okay, so I'm going to say that equals round that 0. Okay, and then I'm going to. This is getting super inefficient, but just again a reminder of why I like let. So I'm going to divide those numbers by whether they're equal to the round version of themselves, and then I'm going to call that again, comma 3. So these are, and then if I divide 15 by that again, actually wait, no, sorry, I can get rid of that and get rid of this. So these are the divisors. Yes, okay, that one has more than 1. So these are the divisors less than the square root. Okay, so it's going to be one of these. So, do I have min? I could really use min here. I have min A, which I think is, for my purposes, the same. Okay, so, wow, really regretting not having let right now, or the ability to flatten this into a row, but fine. So let's do index of this, locking this by that, plus index of this, locking that by this divided by that. 11 and 9, I should be getting 8. Okay, that's not so good. Okay, so then we got 2 and 3, so 18. I can do with 8. 2 times, yeah. So what? Okay, so yeah. Sorry, whoa, so many things going on here. So let's do this part. 6. No. What? 2 times 9, 3 times 6. Yeah. Oh, crap! You're indexing the wrong one, you moron. Alright, sorry. That's just the value that I want. There we go. 8 and 8. Okay. And then I can wrap that in min. Oh, I still need an if. Oh, crap, I don't even have min. Oh, that's super annoying. I wish there was an undo option when that happened. But there ain't. Okay. Fine. Move that. And move this also. Okay, and then min A. Except I don't have an if error, do I? Ah, but I can yeah, I can. Can I? Well, yeah, min A of that and that plus 1. That might not work. No. Okay, so instead of min A, I can v-stack. Maybe? No. Oh, damn it. Okay, I need an if error of some kind here. I don't have if error. It is omitted. Oh, don't I have is number? No, I had it and I lost it. Damn it. Oh! So close to getting this. Okay, hang on. Something has to work here. There is a way to v-stack with an error, I'm sure. Yeah, that works. Ah, no. Is it this? No, it didn't work. Oh, I thought there was. I'm sure there is. Okay. Oh, how do I do this? Oh, I know how I can do it. Let's go back to min A. Do this. Okay, so then we're going to do that. Do this plus 1. These are the 2 candidate values. And then we're going to do equals at sort to call this 3. Boom. Oh, wait, I'm going to check if these are. Yes, I think these are matching values. That should be 8, that should be 9, that should be 9. Be 8, be 8, be 8, be 7, be 8, be 7. Okay, so I think we've got something working now. Now, the next test is does it match the value for the first 100? It's amazing how. Okay, 1113. I think that was it. Yes! Okay, so now we need, the answer is the first 1,000. Okay, and so the sum is 18,274. Have I conquered my first divine challenge despite ridiculous levels of difficulty with if error? Yes! Ah! I get sum square and group by. Okay, well, yeah, those are not totally unhelpful. Okay, I think I need to get if error. Whoever has that, I'm going to go fight them right now. You don't? Who does? I have no idea. Let's see, Benny. You do not. You do have some, which I wouldn't mind getting, but I've made it this far without some. You just have date stuff, right? Date and time. Oh, you have filter. Oh, and yeah, okay. Lorenzo has filter and if error. Fine. Let's fight. Sequence of triangular numbers. Oh, yes, I remember this one. So the sequence of triangular numbers is generated by adding consecutive natural numbers starting 1. Yes, so 1 plus 2, 1 plus 2 plus 3, etc. The factors of the first 7. See that 28 is the first triangular number to have over 5 divisors. Yes. And so I think the question is find the first one with over 500, right? The value of the first triangular number to have over 500 divisors. I saw Bo doing this one. And I think that I can do it in a relatively neat way. So, oh, I still don't have sequence, do I? Ugh, that's another one I should try to get, but never mind. This one, let's just go down to 2,000 for now. And well, let's start at 1,000. So if that is the number, then the triangle, so in general, 2, 3, 4, triangular number is this plus this, and a formula that you can use, let me just see how am I doing on time before I yak too much. A formula that you can use for that is this times this plus 1 over 2. So if these are, if the 1,000th triangular number is going to be 1,000 times 1,000 plus 1 over 2. So these are the triangular numbers. Now what I'm interested in is the prime factors of these, which I'll explain slightly more in a moment, but 2, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and I think that's probably far enough. So what I want to figure out is the highest power of the prime dividing that now. Let's see, 12 or so should be enough. I still don't have sequence, so I'm just going to make my own little sequence up here. 10, 11, 12, 13, 14, we'll go to 15 just to be safe. Okay, so then we're going to say this to the power of, oh wait, sorry, this should really start at 0. This to the power of this, good. So I want that to be less, yes, less than or equal to this. Then I want if that, then that. Otherwise, whenever it's 0, then I want to call that. Ah, oh crap! A typo in the whole thing. God, Harry, you're killing me. I know, it looked like I was using a bad function. Alright, if this to the power of this is less than or equal to that, then, sorry, I should lock that to $A3, then, oh boy, I'm going to be tight on time. I was getting into divine mode where you can sit around and contemplate, but, otherwise whenever it's 0, or what? Oh, sorry, D2 to the power of that, and let's put a dollar on the 2. Okay, I could really use let, never mind. That equals around all that same thing to 0. Then minus, all that stuff. And then I can use some of the squares, because the square of 1 is 1, the square of 0 is 0. Do 0. Ah, good. What? Oh, yeah, sorry, I meant to call that. Oh, let's just say 0, right? I can't say 0 here, I'll say 1. Okay. Then I can sum them up. That's 4. Sum square. So that means the highest power of 2 dividing this is 3, but I'm ending up with a number that's 1 higher than that, which is exactly what I want. Then I want to do the same. So I'm figuring out the divisors of this plus 1, so I want to do the same thing again for replacing this with this plus 1. Wait, no. Yeah. No, I don't just want to add them together, though. What am I trying to do No, I want to multiply them together. Right, so the logic here is that the number of prime factors, sorry, the number of divisors a number has, if it's the product of a certain power of 2 and a certain power of 3 and a certain power of 5 and a certain power of 7. If you have a total of 3 2's in the factorization, which you do here, then you can have 0 or 1 or 2 or 3 of those. If you have no 4's, then you can only have, no 3's, then you can have 0 3's. If you have 3 5's, then you can have 0 1 2 3. So basically multiply 1 plus the number of divisors together, except for 2, because what I'm interested in is the number of the divisors of this. So I'm going to subtract 1 just from that one and make it red to show it's different. I'm probably explaining too much now, because I know I'm doing weird math and some people don't like that, but on the other hand, I gotta get this done and I've got 3.5 minutes left, so let's hurry up. So then this one has a total of 96 factors. 96 divisors, sorry. And the biggest of these is 320. I need one that goes over 500, so let's start at, so this one goes down to 3000, so let's start at 3000. Sorry, I'm not sure I gave it long enough to calculate. Yes, apparently I did. Okay, let's go to 5000. We get to 480, let's go to 7000. 384, really? I think I should have been there by now. Like I said, I haven't done this one before. Okay, well there's one that gets to 576. Seems too big. And sorry, the answer is the triangular number, I think, so it's this one. Oh, I got it. Hooray. But I get minute and time value. Thanks a lot, Lorenzo. Could I maybe have if error instead? Okay. If Lana starts in these cells and moves straight down without using diagonals, how many bananas will she collect? Okay, that's a pretty easy one. Okay, lots of stuff didn't get cleared out here. We'll clear it out. Oops. Copy that over here. Then, yeah, I guess make a second copy. So it's going to be the value below, that's whatever you can collect from the cells below, plus the corresponding cell in the map is equal to a banana. That's it. So that one's a banana, you pick one up, then all the ones above that, you can pick up the one banana below, and then starting from there you can pick up 2, and so on. Alright. Simples. And then we need the same indirect trick as well. And what do we want is the total, yes. Okay, and the total is 32. Hour and second. Thanks a lot, Lorenzo. Hand over the good stuff. Oh, 10,000 of first prime. I'm not sure I'm ready for that one. Do I have reduce? 1. 1. Some. Oh, I do. Okay, then maybe I can do it. Okay, so I'm going to start from 2. That plus 1. Now, to get to 10,000, well, let's just start with something simple. Start with 1,000. I'm going to try and figure out all the primes from here, so we're going to reduce this. I don't know. Let's just do this. Oh, I didn't check if I have lambda. That's kind of important. Okay, so lambda A, B, A plus B. I do, phew. Okay, so then what do I actually want to do? I need to call that B. Oh, I still don't have error checking. God damn it! Okay, oh, and I don't have filter either. God, alright, so let's try this. 2 call. A divided by A equals A equals V times round A over V to 0 decimal places. Sorry. That's getting all the ones that are divisible by 2 thing poles. Not what I want. I don't want that. Yes, except that I want to keep the numbers themselves, so I said plus A less than or equal to V. Okay, so that I think is not going to be efficient, but I think it is going to work. And maybe for now that's enough. Okay, so then okay, so you get 170 from the first 1,000, so I'm going to need much more than that. Let's go with 15,000. Could be slow, but I think it will work. Okay, it's very slow. I might need to think about ways to make it more efficient. Well, actually, I know a way to make it more efficient. We can do a 2-step. Oh, that worked. Alright, so that gives us how many? Oh, that still only gives us 1,000 primes. Okay. Well, then we're going to need much bigger. Alright, so first things first. Let's go back to 1,000 and 1,000. So that gives us a list of 168 primes. And that should be good. That should be good for everything, actually. So then we can reduce the bigger list using just the smaller list. That is much faster. So that gets us back to the same 1,700. Fine. Now let's go to. I guess we need like 6 times that, so let's just go to 100,000, I guess. A little slow. If I had some error checking, I could filter out more cases, but anyway. Alright, so we're very, very, very nearly there now. We're at 9,592 primes. So, let's go to 110,000, I guess. That should be plenty. Yeah, that'll be enough. Let's see. A little slow, but it's gonna do it, I think. I keep saying there's nothing like this case to make you appreciate functions. So index that. Yes! And what do I get for my troubles? Date and day. Lorenzo! Okay, there's not much left, but he's still got if error and filter, and I still want both of those, so I'm going to keep going. Keep banging my head against it. Lana can move down, down, left. I've done this one already. Boo! No fun. Alright, fine. Well, at least I don't have to explain it again. Maybe I can do it faster that way. Okay. So... rid of that. And I want this equals banana. Plus the max of the cells. Yeah, the cells below. And then the indirect trick again. Okay, and it's almost 29. I swear it's not what I got before, but never mind. Is it a different one? Okay. Well, I got if error at last. I still don't have filter. You know what? I don't care too much. Who has sequence? That's the other one that would be helpful. You don't. Lorenzo doesn't. Maybe Bo. Nope. Who does? Maybe Elliot? Oh, search. I don't have either find or search, which would be helpful. She's got mid and some useful text stuff. I don't know. I kind of want to go back and do another divine challenge and then call it a day. But I got ifs. What was I looking for? God, sequence. I was looking for sequence. Yes. You don't have it. You don't have it. Who has sequence? I don't know. Giles, I know, just has weird stuff. Jack, I think, just has text stuff. But let's check. Yeah, no. Maybe Andrew has it. Should have battled him more at the start if he does. Yes, he has sequence. And a bunch of stuff that I don't really want, but okay. I think he is an easy one, which is odd for him being Andrew. Oh, how many prime numbers are less than 1,000? Okay, well I guess that's just do the thing you just did again. Okay, so reduce this, and I only have to go up to like 32. Lambda A B to call A divided by. It's either A less than or equal to B, or A is not equal to B times round A over B 0. 3. Huh? What? What? What the heck are you talking about here? Just do A1 first. Ah, right, because you started with 1, because you're a moron. What is... Oh, right, you could have 2 hits. You could have 2 hits, you could have 2 hits. So, fine. Wrap all this and say greater than or equal to greater than 0. How about that? Yes, there we go. And the answer is 168. Boom. Abs, atan, and int. Okay, int is actually kind of helpful, but yes, you've still got sequence. Gimme. Gimme sequence, Andrew. Hand it over. 2520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest number divisible by 1 to 20 with no remainder? Alright, so this is all about primes again. So we've got 2, 3, 5, 7, 11, 13, 17. That's it. So the highest power of 2 dividing a number up to 20 is 4. Highest power of 3 is 2, 3 squared, and then all the rest is just 1. So it's going to be this to the power of this, and then it's going to be this times this to the power of this. And so the answer should be that. No. What? What are you talking about? Oh, maybe I've got the parentheses wrong. Does that change it? No. What? What? I'm getting very confused. Let's do the 10 ones. So 3, 2, 1, 1. This, this. Times that. Is 2520, okay. What am I missing? 1 to 20. 2, 3, 5, 7, 11, 13. So, oh, I forgot 19. That's what I'm missing. Bloody plan. Alright. There we go. Okay, I got sequence and square root. Happy days. Alright. Time to try one more divine challenge, and then I'm going to call it a day. had seen that integer complexity one before, and I've seen one other one before, but I have not seen most of the divine challenges, so I'm hoping to see something I have not seen before. Let's see. Oh, 15 minutes for a divine challenge. Yikes. In the United Kingdom, the currency is made up of pound and pence. There are 8 coins. It is possible to make 2 pounds in the following way. How many different ways can 2 pounds be made using any number of coins? Okay. So... So, how do you think about that? Well... First we think about how many ways something can be made with 1 coin. Up to 200. So with 1 coin, it's just that. If you can use 1 and 2, if you can use up to 2, then it is what? So, oh, I still don't have sequence to it. No, I got, did I? I can't remember. Yes, I got sequence. Hooray! I'm gonna need it. Okay, so, sequence this over this. Start at this. Just do that. That can be calc. Unhelpful. Fine. Let's just lock and lock. Okay. So then it's going to be this minus this times this. Okay. So we're going to index in here by that and add that. So you can do 5, 3, yes, okay. And then have I got min? You can still, yeah, min A, but not min. Ooh, sorry, whoops, min. Min A, sorry, whoops. Okay. So the best you can do with 2's and 1's are 7, yeah, that's good. And then I just need an if error. I guess the answer is just if error. Then having this coin will not improve your lot. And that is exactly what you'd expect. It goes 1, 2, 2, 3, 3, 4, 4, 5, 5, etc. So then if we add in a 5, no help up until 5, and ooh, why is it 2? It shouldn't be 2. Ooh, it's 2 because... Wait, what is going on? 5 minus sequence... Oh, right, the zeros. Okay, so we need a 0 here. And the answer is 0, 0, 0. And then we need this index to go up to there. Oh, and then I guess that means we also need to be... yes, we need to be that. All that nonsense, minus 1. For the row number, sorry, plus 1. Row numbers and all that stuff, plus 1. Yes. That was me confidently saying that it made sense, that it was 1, 2, 2. Anyway, sorry. Nonsense, but... Okay, so now you can do 5. 1, yes. Okay, so now the next is 10, 20, 50. 10, 20, 50. 100, and that's it, right? Oh, no, we have... Wait, what? Oh, okay. Oh, we have 200. Ah, no, wait, I'm figuring out the minimum. I need to figure out the number of ways. Oh, crud. Ooh. Okay. So, sorry. Slight, not a huge change in the formula, but a slight change in the formula. So... it's some square, I guess that'll do. Right. Okay, so I'm gonna just get rid of all this. No, sorry, get rid of some bigger one. Go to 16. Okay, so get rid of the index. So, sorry, probably not the index. Okay, So now I need this to be the number of ways. So the number of ways you can make 0, yeah, so there should be 1 for all of those. And then it's going to be, I guess, that to the power of 1/2, and then I can some square it. Okay. Oh, sorry, back to the if error. If error, then a 5 doesn't add anyways, in which case it's that, yes. So, yeah, that should be, and this should be coded in. Okay, so this says there's 1 way to make it 2. There's not. That does not add up. There should be 2. Yeah, that's not good. Ooh. Okay. Yeah. Okay. So we need to add 1. I think that's still not working. Why? Let's add 2. Still, what the heck? Come on. What? Okay, hang on. Okay. Sorry. What are we trying to do here? Okay. So, sequence, get rid of that. All of that. Let's keep it on. Plus 1. Still says 1. Why? Oops. Oh, what? Value error? Huh? Okay. 1 minus 1. Ah, okay. Yeah, no, you need to have a 0 option as well. Oh my god, what is going on here? Okay, just start from something cleaner, please. Let's say I want to do 14 and 2, so it's going to be sequence. So 14, there'll be 8 options. 15, there'll also be 8. So it's this over 2, that over 2. Maybe this, no. Yes, this plus 1 over 2. This over 2 plus 1 over the, getting totally lost here. Did I get int along the way? I think I did, yes. Int of that plus 1. I think that's the right number. That's 8, that's 9, that's 8, yeah, okay. And then if I were going in 5s, 3 there, 4 there, yes, okay. So it's int of that over that plus 1. So, sequence of int of that over that, starting from, ooh, sorry. Start from here in steps of minus this. And then we still on plus 1, I think, yes. Okay. No, what the hell? Oh my god, this is so annoying. Oh, sorry, yeah, into that over that plus 1. Okay, finally. Okay, that looks more like it. Okay, so I think the answer is this. Which is a very large number, but it's not the answer. Just open up these ones. Hang on. With a 5p. You can do 5, or you can do 2. Yes, that seems to be working. Oh, that's not right. What? With a 10p, you should definitely have all the 5p options. So that's something's not right there. It should never go down. So what is this sequence doing? That's 5. So, yeah. Ah, sorry, you closed the bracket wrong. Damn it. Oh, the things that kill you. Okay, so that will put in change. That changes, that changes, that changes, that changes, that all changes. Now is my 10 answer plausible? Yes, nothing should change below 10. And then you should have one more way above that, and then many more ways eventually. Okay. Yes! Boom! Okay, well you gave me crap for it, Michael. Thanks a lot, but still, that is 2 divine problems down, and bumps my ranking up to team lead. Cool. Alright. I think I'm gonna call it a day, and then I'll try and tackle maybe some more divine problems tomorrow or at some point soon. Alright, that's all I got for today. Thanks for watching. See you next time.